Hey Weintek warriors, today we're going to cover some of the amazing features of our CMT series HMIs. So grab your popcorn and brace yourselves for a wild ride. To download EasyBuilder Pro, head to the Downloads section of our forum at forum.weintechusa.com. There you will find the latest version of EasyBuilder Pro. When you first open EasyBuilder Pro, you will need to choose your HMI model. Let's select a model from the cMT-X series. We'll leave Use Template selected. This option will generate pre-made system windows, keypads, and other windows that'll come in handy when building your project. After choosing your HMI, you'll be greeted by the System Parameter Settings. Here you can configure many important settings within your application. Within the Device tab, we can add an external device that will be used within your project. Select the New Device/Server button, and select the device type drop-down list to choose a driver. We're going to search Rockwell, and choose the Rockwell Ethernet IP CompactLogix free tag names driver. Now that we've added our driver, let's upload some tags. With the device selected, click the Import Tags button. You will then be prompted to select your tag's file type. We're going to select L5X for this demonstration and navigate to our tag file. In the following window, you can select which tags you'd like to import. I'm going to select all and click OK. You will see the Tag Import Success message upon completion. You could also select the Get Tag Info button, but this can only be used when your PC is connected to the PLC via an Ethernet connection. We're also going to add a Modbus RTU device. Again, we're clicking on the New Device/Server button and selecting the device type drop-down list. We're going to search Modbus and select Modbus RTU over TCP. Selecting the Settings button will allow us to configure COM port settings and IP address settings for Ethernet devices. Let's take a quick tour around EasyBuilder Pro. Here in the middle is your work area. This is where you will be placing your objects and designing your UI. You can find your windows in the window tree to the left. Our software is super intuitive and easy to use. We have 8 tabs related to project development. The Home tab is where you can find the system parameters, used to establish communication with external devices. The Project tab is home to our libraries and simulation features. The Object tab is where you can find the objects used to control and monitor your device. The Data/History tab is where you can configure data logging and create alarms for your device. The IIoT/Energy tab is where you can define an MQTT server. The View tab is where we customize the look of EasyBuilder Pro. The Tool tab houses some of our external tools. And finally, the WinCloud tab is where we configure WinCloud connectivity. We've just scratched the surface of the features packed within these tabs, but we're just covering the basics for this demonstration. Let's head to the Object tab and create our first object. Select the toggle switch to begin object configuration. In the Read Address section, you will see the devices we added earlier in the device drop-down list, as well as the local HMI. We're going to select our CompactLogix and a PLC tag we imported earlier. Our toggle switch is now configured to represent data from this read address. Let's head down to the Attribute section. In the Switch Style drop-down list, we've got a few options to choose from. We can set our bit either on or off, or toggle between the two. We also have the momentary option. With this option, the switch will stay at state 1 as long as it's held. When the switch is released, it is returned to state 0. Let's take a quick peek at the Shape tab. We can view the switch's different states by selecting its number. By default, the toggle switch uses a 2-state image of a blue switch. For certain system libraries, you can change the color of a state by using the color drop-down list. If you'd like to change the image, select the Picture Library button. Here, in the Library tab, you can choose another look for your switch. There are plenty of options to choose from. In the Project tab, you can import images into your project file. Select Browse Libraries to check out even more image options. Let's head on back to the Object tab to check out the Combo button. The Combo button is used to perform a list of sequential actions. Selecting the blue plus sign allows you to add an action to the Combo button. And as you can see, we've got plenty of options here. We can configure the button to perform an action when it's pressed down, or when the button is released. Let's add a set bit action and address it to the toggle switch we added earlier. Next, let's add a delay of 1000 milliseconds, or 1 second. Finally, let's add another set bit action, but have it turn off the switch. If you'd like to delete an action, just select the red X. If you'd like to rearrange your action group, just drag the action to its desired position. You can also open the action groups in a separate window. This is helpful when configuring multiple action groups. Within the Lamp section, you can configure the Combo button to function as a bit or word lamp. When an object is selected, you'll see these small blue squares along the perimeter. Click and drag one of these squares to resize the object. Now that we've covered a couple of objects, let's create a new window. First, let's head to the View tab to confirm that Windows Tree is enabled. When enabled, you will see the Windows Tree pane on the left side of EasyBuilder Pro. To create a new window, right-click on any available window within your project and select New. You can change the name of the window in the Name field. I'll call mine Data. You can also change the width and the height, which comes in handy when creating pop-up windows. You can also change the background color of the window. Let's create a common background window, or an underlay window. These come in handy when you would like the same objects on multiple windows. For example, you may want an underlay window with buttons used to navigate around your project. I'm going to create a new window called Underlay and add it as the bottom underlay window for our home and data windows. Next, I'm going to add a rectangle shape along the bottom of our underlay window and add a couple of function keys that will navigate to our home and data pages. Within the Attribute section, ensure that Window is selected. Within the Window section, choose Change Full Screen Window from the Function drop-down list and select the appropriate window from the Window Number drop-down list. I'll now head to our Project tab and run an offline simulation so we can see our Underlay window in action. Next up is the Numeric object. Head on over to the Object tab and select Numeric. Let's select our local HMI from the device drop-down list and keep the address of LW0. Within the Format tab, you can define the data format of your read address. We can also configure the display format, the number left and right of the decimal point, or you can further customize your character count. We can also set low and high limits for the value entered into the Numeric object. Let's choose 16-bit unsigned as our data format and slap this object on our project. Let's head back to the Object tab and select the ASCII object. The ASCII object is used to read and write string data. ASCII objects support multi-line display, input masking, and reversal of the high and low byte. To change the word or character count for the object, select the Settings button located in the Read and Write section. In the Number of Words field, you configure character length at 2 characters per word. Let's create a pop-up window. On the Windows tree on the left side of EasyBuilder Pro, right-click an available window. I'm going to select Window 100 and select New. Because it's going to be a pop-up window, I'm going to decrease the width and the height. Next, we'll choose a new snazzy color for our pop-up and select Monopoly. Monopoly ensures that any object behind the pop-up window cannot be interacted with until the pop-up window has been closed. Select OK when finished. Next, navigate to the Object tab and select the Function key. In the Function key, confirm Window is selected from the Attribute Type drop-down list and choose Display Pop-up Window from the Window Function drop-down list. In the Window Number drop-down list, choose the newly created pop-up window, and then we'll run a simulation to check out our new pop-up window. Next up, the beloved action trigger. Head on over to the Object tab and select Action Related. When selected, you'll see that Action Related has 2 options. Action Trigger per page allows us to perform a list of sequential actions, not unlike the combo button. These actions will be triggered by whichever option you choose from the Action Trigger drop-down list. Actions can be triggered by a window opening or closing, a changed value, or the turning on or off of the HMI's backlight. Action Trigger Global can also perform a list of sequential actions, but is not limited to a specific page. The actions can be triggered throughout the entire project based on what is chosen from the Mode drop-down list. The trigger can be based on idle timeout, a changed value, a control token, user secure access, or a condition object. Let's take a closer look at the action trigger. I've chosen Value Changed from the Mode drop-down list, and Bit for the trigger type. I'll configure our address to be LB100 and choose On for the trigger condition. I'll choose a set word action and write a constant string of hello to LW200. I'll also change the number of words to 3. Now let's run a simulation. You'll see that when LB100 turns on, our hello string will appear in LW200. Now that's action. Let's talk about user account controls. Let's say you want to restrict an object so that only a manager or someone with higher permissions can interact with, or even see it. An object or window that you do not want the operator or anyone without the proper permissions to mess with. Well, the solution to that is class-based permissions. If you look at the properties of the function key we created earlier and head to the Security tab, you will see the User Restriction section. Here, you can choose an object class that will determine who can access it. Only users with that object's class permissions will be able to interact with or even see it depending on which option you choose below. Below, you have the option to disable protection permanently after initial activation. You can display a warning message if access is denied, or you can make the object invisible while protected. Let's choose a Class A user restriction for this function key. Now, we just have to create a user and give them Class A object permissions. To do that, head to the Home tab and select System Parameter Settings. Within the System Parameters, select the Security tab. Here you can create a new user, give them a password, and select which class permissions they will be able to access. Be sure to select Enable, or you will not be able to log in as the user. You may be wondering, how do I even log in? Well, we've made it simple. We have some great pre-made UAC-related windows, but we're going to focus on Windows 70. This pre-made window will allow us to choose a username from a drop-down list, enter your password, and log in and out. I'm going to create a function key that will change the window to Windows 70. Let's run a simulation to see the class-based user permissions in action. It's time to create an alarm. Navigate to the Data/History tab and select the Event Alarm log. This is where all alarms are configured. In the following window, select New to define an alarm. In the Event Alarm log window, in the General tab, you can select the type of data that the alarm will be monitoring, either a bit or a word value. With words selected, we have a list of enable if value is conditions. And as you can see, we've got all the usual suspects here. We'll select bit for now. Below, in the condition section, we can select the trigger condition for the alarm. Let's choose on for this demonstration. In the message tab, we can configure what we would like the alarm message to say. You have the option to use a message from your label library, which comes in handy if you have a project with multiple languages. At the bottom of the window, we can define a multi-watch address. Here, we can read data from a device and use the syntax to display that data within the alarm's message. Now that we've created our alarm, let's take a look at the History/Control tab. If you enable History, alarm records will be saved to the location of your choice, to the HMI's memory or USB disk. You can also set a preservation limit for how long you'd like to store alarm data. With history enabled, you will also be able to view past alarm info in an event display. Now that we've configured our first alarm, let's head back to the Data/History tab and select Event Display. The Event Display object will allow us to view past and active alarm events. The acknowledge address is often tied to an indirect window or pop-up that will use the acknowledge value from an alarm to determine what pop-up is displayed. For example, the window could give instructions to the operator when the event is selected, which can be further configured in the Message tab in the Event Alarm Log. In the Event Display tab, we can configure how the object looks. Next, let's head to the Sort tab. Here we can choose what information we would like to see on the Event Display object. I'm going to select Trigger Date. Now let's place the object into our project and create a switch to trigger our alarm. Let's run a simulation to see the alarm in action. Let's talk about the data transfer. When you're transferring data from one device to another, for example, a Modbus RTU device to a CompactLogix, you may end up using a data transfer to perform protocol conversion. However, the HMI must be connected to each device and actively polling data before performing protocol conversion. Head on over to the Object tab and select Data Transfer. When Data Transfer is selected, you'll see two options: Data Transfer Per Page and Data Transfer Global. First, let's select the Data Transfer Per Page option. This option can only be used within a single window and not globally throughout your project. In the General tab, in the Mode drop-down list, we can choose how the data transfer is triggered. Here, you can also choose the data transfer source and destination. Let's choose the Modbus RTU device as our source and the CompactLogix as our destination. Select OK to place the object within your project. When the button is pushed, the data transfer will execute. Next, let's take a look at Data Transfer Global. We have two tabs. We can transfer data on a set time interval or when triggered by a bit. Let's create a new time-based data transfer. In the Attribute section, we can also choose to transfer word or bit data and choose the time interval for the data transfer. And like the Per Page data transfer option, we choose the source and destination of the data transfer. Please note that the Data Transfer Global object does not allow bit data to be transferred via some devices. It's time to do some data sampling. Head to the Data/History tab and select Data Sampling. Within the following window, select New to sample a new set of registers or tags. Next, we have the choice to sample data based on a set time interval with the time-based option, or we have the option to configure trigger-based data sampling. We'll stick with time-based for this example with an interval of 1 second. Select the Settings button to define the data that you would like to sample. At the top, select the device that the data will be sampled from. Select New to add a new register or registers. They can be contiguous, or you can add up to 8 non-contiguous registers. You can give each data point a description. This description will be used in the Trend Display object and when exporting to a CSV. Next, we'll specify the device address and data type. Let's talk about the history file within data sampling. Enabling the history file will allow you to save sample data to HMI memory, USB, or a SQL database. You can also customize how you would like the data to be saved to a file and configure how long you would like to preserve data records. When USB disk or SD card is selected and the number of records reaches 10,000, the system will automatically save the sample data to an external device and delete the earliest 1,000 records on the HMI. Please note that if the external device is removed from the HMI and reinserted at a time when the sample data is under 9,000 records, the data generated during the time the external device is removed is saved in the HMI and is not cleared. If the data exceeds 9,000 records during the time the external device is removed, the earlier data is cleared and cannot be synchronized, even to insert the external device back into the HMI. Now that we have configured data sampling within your project, let's navigate to the Data/History tab and select Trend Display. This object will allow us to view the data we're sampling. In the General tab, let's choose Time for the X-axis time range, and a distance of 120 seconds. Next, in the Trend tab, let's enable the grid. In the Y-Scale tab, we can enable the Y-Scale for our data points as long as grid is enabled. Click OK and place this object within your project when finished. Let's create a numeric object and run a simulation to see this trend display in action. Next up, we have the History Data Display object, which can be found in the Data/History tab. The History Data Display object shows the data from the data sampling object that we configured earlier. In the General tab, we're able to choose a color, font style, and font size for the object. In the Display tab, we can choose if we'd like to see the time and the date of the events. Let's run a quick simulation so we can see the historical data display object in action. You've seen me run a few simulations so far in this demo, so let's talk about it. To simulate your project with an EasyBuilder Pro, you must first save it. Head to the File tab and select Save. Next, head over to the Project tab. Here you will find two simulation options, online and offline simulation. Offline simulation is great when you'd like to run a simulation without being connected to an external device. Online simulation is the opposite. Your PC must be connected to any remote devices you have configured in your project to communicate with them, or you will receive an error message. It should be known that simulation is not a remote connection to the HMI, and that you do not monitor the HMI when simulation is in effect. Alright, it's time to configure a PLC web browser. The PLC web browser can be used to view the web interface of an external device, such as a PLC. Head to the Object tab and navigate to the Media drop-down list. Here, you will find the PLC web browser. Within the General tab, you can enter a default URL, which is essentially the home page of the browser. You also have the option to show the browser's navigation bar. If Control is enabled, you can configure a control address. Selecting the blue hyperlink reveals the command IDs. We can also define a device address for either the current or the destination page. Let's run a quick demo to see the PLC web browser in action. I'm accessing the HMI via its web servant. and it is connected to a CompactLogix. When I enter the PLC's IP address into the PLC Web Browser's address bar, we can see the CompactLogix's web interface. As you can see, we can navigate around using our mouse, or, if you're on the HMI itself, you'd use your finger to navigate. To download your project to the HMI from within EasyBuilder Pro, navigate to the Project tab and select Download PC to HMI. On the following window, select Search All to find your HMI. But please note that you must be in the same subnet to discover it. Select your HMI and click the Download button. Thanks for watching. If you found this video helpful, head on over to our channel for more great technical tutorials. And come on down to our forum. It's a great resource for everything Weintek.